bersatu kita warga UiTM, kita bangsa perkasa, taat dan setia untuk negara, penuh semangat wajar. Kita jangan mudah terlupa pengorbanan perjuangan anak bangsa. Kita jangan mudah terleka kemajuan keamanan yang ada. Kita berterima kasih pada pemimpin-pemimpin negara. Kita rasa penuh bersyukur kerahmatan kemuliaan darinya. Kamilah pendukung pewaris bangsa, kamilah penolong bangsa Malaysia, kamilah warga berwawasan untuk negaraku.
Yang berbahagia, Profesor Teknologis Dr. Salmiah Kasolang, Rektor Universiti Teknologi Mara, Cawangan Pulau Pinang, Malaysia. Yang berusaha, Profesor Madya Insinyur Dr. Ahmad Rashidi Razali, Deputy Rector of Academic Affairs Universiti Teknologi Mara, Cawangan Pulau Pinang, Malaysia. Yang berusaha, Profesor Madya Kemis Dr. Nur Aziah Bakari, Deputy Rectors of Research Industry Network, Alumni and Community Universiti Teknologi Mara, Cawangan Pulau Pinang, Malaysia. Yang berusaha, Teknologis Dr. Muhammad Ruzaiman Aziz, Deputy Rectors of Student Affairs, Universiti Teknologi Mara, Cawangan Pulau Pinang, Malaysia. Yang berusaha, Dr. Haji Anas Ibrahim, Honorary Chair, The International Conference on Advanced in Civil Engineering and Science Technology 2021 and Head Center of Studies, Civil Engineering Studies, UiTM, Cawangan Pulau Pinang. Associate Professor Dr. K. Dora Abdul Ghani, Conference Chair, The International Conference on Advanced in Civil Engineering and Science Technology 2021, keynote speakers, strategic partners, sponsors, distinguished guests, organizing committees, and participants, the International Conference on Advanced in Civil Engineering and Science Technology 2021. Assalamualaikum warahmatullahi wabarakatuh and welcome to the International Conference on Advanced in Civil Engineering and Science Technology 2021. I am Technologist Muhammad Samsuddin Abdul Hamid, will be Master of Ceremony for today's event. This opening ceremony is bringing to you live through UiTM CPP YouTube channel and Pusat Pengajian Kejuruteraan Awam UiTM Cawangan Pulau Pinang Facebook page. Ladies and gentlemen, the International Conference on Advanced in Civil Engineering and Science Technology 2021 is organized by School of Civil Engineering, College of Engineering, Universiti Teknologi Mara, Cawangan Pulau Pinang, and co-organized with Structural Engineering and Seismic Research Group SISMOS, Permanent Way Infrastructure Research Group PWI, Institute of Infrastructure Engineering and Sustainable Management ISM, and Rehabilitation, Repair and Retrofitting 3R Research Group. Icacest 2021 carried out a theme, Re-engineering Cultures of Science and Technology, on creating sustainable development through IR 4.0 as it goes to new revolution in research and development. This year, the conference is finally decided to be virtual conference due to pandemic COVID-19 since December 2019, it's attacked the whole world. But this situation is not stopping us from moving forward to share and collaborate in producing new finding and innovation in civil engineering, science and technology. After hosting a successful first and second edition of the International Conference on Advanced in Civil Engineering and Science Technology in 2015 and 2018, Then the third edition is happening now on the 21st to 22nd September 2021. We use the overwhelming positive feedback from our past attendees to create an even bigger and better event that will continue to offer its attendees relevant content delivered by prominent speakers in the respective field. Icacest 2021 is also happening with full support from our strategic partners, University Science Malaysia, Construction Industry Development Board, CIDV Malaysia, Construction Research Institute of Malaysia, CRIM, Universitas Malikus Saleh Aceh Indonesia, and Kim Mongkut Institute of Technology Lakrabang, Thailand. Ladies and gentlemen, to begin the ceremony with blessing from Allah Subhanahu wa Taala, I would like to invite Yang Berusaha Dr. Imaduddin Abdul Halim from Academy of Contemporary Islamic Studies, UiTM Cawangan Pulau Pinang, to lead the doa recitation and a moment of silence. Please welcome.
الفاتحة. بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. بسم الله الرحمن الرحيم الحمد لله الذي جعل أول يومنا هذا صلاها وأوسطه فلاها وأخيره نجاحا والصلاة والسلام على أشرف المصطفى سيدنا محمد وعلى آله وصحبه ومن اهتدى. اللهم يا رحمن يا رحيم, we express our gratitude to you for allowing us to attend the opening ceremony of the International Conference on Advances in Civil Engineering and Science Technology 2021 on this auspicious morning. Ya Allah, we ask you for the safety of our religion and the welfare of our body. O Allah, Lord of the implementing authority, make the days that we gone through, starting with your mercy, continue with your blessing, and ended with thy forgiveness. And also make the days that we gone through with guidance, and end with the victory of excellence. Ya Allah, Ya Muhammad, Ya Azir, Ya Jabbar, show us guidance to achieve happiness and glory. Let us listen to people who like the good things, and let us avoid doing the bad and evil things. O Allah, bless us our life in this conference and prevent us from harm and unfortunate event. Ya Allah, Ya Faraj al-Ham, wa Ya Kashif al-Gham, let our effort as a being to enlighten and convince ourselves that the personal safety of either outer or inner is a prerequisite for achieving happiness and excellence in our fields. O Allah, grant us faith and strength in order to face the challenges of life during this COVID-19 pandemic. Allahumma inna a'udzu bika minal barasi wal jununi wal juzami wa min sayyi'il asqam. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa baraka sallam. Walhamdulillahi rabbil alamin. Amin ya rabbal alamin.
Amin amin ya rabbal alamin. Thank you Yang Berusaha Dr. Imaduddin Abdul Halim for the doa. May our event run smoothly and be blessed by Allah Subhanahu wa Taala insya-Allah. Ladies and gentlemen, now I would like to invite Yang Berusaha Associate Professor Dr. K. Dora Abdul Ghani, Conference Chair of the International Conference on Advanced in Civil Engineering and Science Technology 2021 to deliver her welcoming speech. Please welcome.
Thank you, Professional Technologist Dr. Muhammad Samsudin Abdul Hamid, our Master of Ceremony. Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. Assalamualaikum warahmatullahi wabarakatuh. Yang berbahagia Profesor Teknologis Dr. Salmiah Kasolang, Rektor Universiti Teknologi Mara, Cawangan Pulau Pinang. Yang berusaha Associate Professor Insinyur Dr. Ahmad Rashidi Razali, Deputy Rector Academic Affairs, Universiti Teknologi Mara, Cawangan Pulau Pinang. Yang Berusaha Associate Professor Chemist Dr. Nur Aziah Bahari, Deputy Rector Research, Industrial Network, Community and Alumni, Universiti Teknologi Mara, Cawangan Pulau Pinang. Yang Berusaha Dr. Haji Anas Ibrahim, Center of Studies, Civil Engineering Studies, Universiti Teknologi Mara, Cawangan Pulau Pinang, the Honorary Chair of Icacest 2021. UiTM Cawangan Pulau Pinang Executive Members, Head of Departments, respective keynote speakers, co-organisers, strategic partners, sponsors, honourable guests, ladies and gentlemen. Alhamdulillah, let us extend our sincere gratitude to Allah Subhanahu Wa Taala for giving us the opportunity to hold the International Conference on Advances in Civil Engineering and Science Technology, Icacest 2021, organised by School of Civil Engineering, Universiti Teknologi Mara, Cawangan Pulau Pinang. It is my utmost pleasure to welcome all participants to our virtual conference, which brings together experts and academics from around the world. After hosting the successful first and second edition of Icacest in 2015 and 2018, again, we are now having the third Icacest from the 21st till the 22nd September of 2021, the first conference which is conducted virtually. With the theme Re-engineering Cultures of Science and Technology in Creating Sustainable Development Through Industrial Revolution 4.0, this conference aims to foster further collaboration and exchanging new ideas between researchers, academicians, and industrial professionals from all over the world in the field of civil engineering, science, and technology. Ladies and gentlemen, learning and collaboration are the core of Icacest 2021. We are proud to have good expertise in many engineering areas and look forward in establishing meaningful collaboration for mutual benefits. We welcome feedbacks and comments to further improve our future events. Thus, I would like to take this opportunity to express my heartfelt appreciation to all parties who have directly and indirectly contributed toward the success of this auspicious event, especially the committed and passionate committee members, keynote speakers, reviewers, juries, guest speakers, presenters, and all participants. May Allah Subhanahu Wa Taala reward you greatly for your good efforts. Thank you very much for your participation, and we hope to welcome you again in the next Icacest 2024. Assalamualaikum warahmatullahi wabarakatuh, and have a great day. Okay, back to you, Mr. Samsudin.
Thank you to Yang Berusaha Associate Professor Dr. K. Dora Abdul Ghani for her welcoming speech. Next, I would like to invite Yang Berusaha Dr. Haji Anas Ibrahim, Honorary Chair, the International Conference on Advance in Civil Engineering and Science Technology 2021 to deliver his speech. Please welcome Dr.
Thank you very much to our Conference Master of Ceremony, Technologist Dr. Muhammad Samsudin Abdul Hamid. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya wal mursalin. Wa ala alihi wa ashabihi ajma'in. Rabbi shrah li sadri wa yassir li amri wa hlul uqdatan min lisani yafqahu qawli. Assalamualaikum warahmatullahi wabarakatuh, and very good morning everyone. Yang berbahagia Profesor Teknologis Dr. Salmiah Kasolang, Rektor Universiti Teknologi Mara, Cawangan UiTM Pulau Pinang. Yang Berusaha Associate Professor Insinyur Dr. Ahmad Rasidi Razali, Deputy Rector Academic Affairs UiTM Cawangan Pulau Pinang. Yang Berusaha Associate Professor Chemist Dr. Nur Aziah Bahari, Deputy Research Industrial Network Community and Alumni UiTM Cawangan Pulau Pinang. To all UiTM Cawangan Pulau Pinang Executive Members, Head of Department, respective keynote speakers, strategic partners, sponsors, distinguished guests, ladies and gentlemen. I wish to welcome all participants to the International Conference on Advance in Civil Engineering and Science Technology, Icacest 2021. This event marks the consistent and persistent effort of Civil Engineering Studies, Universiti Teknologi Mara, Cawangan Pulau Pinang. We are truly values your participation in this conference. In line with the UiTM motto, Unleashing Potential, Shaping the Future, this conference will be a scientific platform to highlight the latest development in the field of civil and infrastructure engineering, environmental engineering, science and technology, geophysics, and engineering education. This conference will bring together local and international academicians, practitioners, and graduate researchers to share their ideas, findings, and research conference in various aspects of knowledge related to the field. I believe Icacest 2021 allow us to expand our horizon in civil engineering and science technology, which lead to a stronger network for future research and academic collaboration. I would like to congratulate the Icacest 2021 Chairman, Associate Professor Technologist, Dr. Kedora Abdul Ghani, and all hardworking organizing committee for their diligence and enthusiasm in organizing the conference. I convey my best wishes to all Icacest 2021 participants and wish that this conference will be successful and bring an exhilarating and valuable experience to all. Hopefully, in the near future, we can have a conference next to the beach and beautiful scenery. With that, thank you very much, everyone. Assalamualaikum warahmatullahi wabarakatuh. Back to you, Mr. Chairman.
Thank you Yang Berusaha Dr. Haji Anas Ibrahim for his speech. Ladies and gentlemen, let's continue our session with the first keynote speaker. Before that, I would like to remind all participants, if you are interested to ask questions to our keynote speaker, please write down your question in our chat box in YouTube and will be read later on to the keynote speakers. Now, I would like to welcome and introduce our honorable keynote speaker for this session, Yang Berbahagia Professor Dr. Zakia Ahmad, who will speak on how Industry 4.0 is driving the innovation in timber construction. Ladies and gentlemen, let me introduce our keynote speaker's background. Yang Berbahagia Professor Dr. Zakia Ahmad is the Dean, Research and Innovation, College of Engineering, University Teknologi Mara. Yang Berbahagia Professor is specializing in timber engineered composite and nanopolymer composite. Up to this date, she has secured and leads more than 50 numbers of research grant and consultancy worth more than RM20 million. She has published more than 300 papers in journal and proceedings as well as 8 books. She has received several gold and silver awards on her research project at national and international research competition. She is the recipient of the Top Research Scientist Malaysia, Standard Malaysia Award, Best Researcher Award, Gold Consultant Award, and Best Academic Awards. She also active in giving keynote papers at numerous seminars and conferences at national and international level. She also has served as consultant, committee member, and advisor to numerous public agencies and institutions. Without further ado, I am honored to hand over this session to Yang Berbahagia Professor Dr. Zakia Ahmad. The session is yours.
Bismillahirrahmanirrahim. Okay, thank you, Mr. Chairman. Yeah. Okay. I know that Prof. Dr. Salmia is not around, not here yet. Okay. So to all honorable speakers, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Okay, today will be have the opportunity to share with you in some of the work that I have done and how to drive the IR 4.0 in Malaysia. So I'll do my sharing now. Okay, can you all see me?
Wait for a while, Prof. Okay.
Oh. Because I can't see all of you because I cannot change my screen to
Yes, yes, it's okay.
different form.
So we can see your slide. So you can put it into slideshow mode now. Okay, you may start your session now. So I will leave the session to you.
How can we do the slideshow? Okay, can you see? Can I? All right.
Okay.
Okay. Now, in order for us to drive the IR 4.0 in timber industry, the production of the timber must be in huge volume and the design must be complicated and so on. Yeah, that's where the need of technology in order to produce the timber products and also in the construction of high-story buildings in timber. So we know already now the timber are in small diameters, not like previous where we have large diameters, and they are in Malaysia especially are very limited. And our timber are hardwood timber compared to European and other countries that timber are softwood timber. There's a lot of studies has been done in order to use their softwood timber in high-rise building, in mass timber technology and so on. Yeah, but in Malaysia, the study on the timber are still limited. So I hope in this by giving this talk, there will be more researchers that will be interested in conducting research in timber. All right, and you can see that behind my photos, that's the current log. Okay, that's in obviously their standard size are about the same. They have management plantation. They know when to cut the trees and to be used for the industrial purposes. Okay, but at the same time, when we are dealing with timber, which are natural product, not like concrete, not like steel, the properties are not easy to in order to make it consistent. Therefore, there must be technology that can make the timber product more consistent, dimensional stable. Yeah, it's much easier to predict the performance and so on. So therefore, this timber product needs to be converted into an engineered timber product. Okay, these are some of
Sorry,
the,
Prof.
yeah,
Can you please put in the full screen mode?
I have done it. I've done it. You can see?
Yeah.
Just one.
Just press the slideshow mode.
Okay, I'm looking for it. Let's show.
From beginning.
Now, is it okay? I can see mine.
You have to choose an entire screen.
Okay, I'll stop sharing.
Okay.
Okay, I'll share screen. Um, no, it doesn't work. I already
Okay.
clicked my entire screen, but it doesn't work. I can only do
Okay.
from my window.
Okay. We just continue in the like the previous one.
Let me see. Hmm. Hmm. Tengok. Wait, 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 wait. No, it doesn't. It doesn't work. It doesn't work. Maybe I don't know how to use it. Sorry. Sorry. What should I do now? Because when I click entire screen, they only show our screen now. I didn't have my slide on it.
So you have to open up your PowerPoint and then you share with us.
Yeah, I already opened up. It's already open. It's open. At the back, the whole slide is open. So then when I go to my share, all right, as normal, okay, the entire screen doesn't have another screen that shows my slide. Only when I do the window, I can see the slide. So never mind. Can I go by if not, I will
Yes.
take up so much
Yes.
time, yeah? All right.
Yes.
So I'll do the sharing. So you can only see, because I can't see all of you now. I can't see my screen because just now I tried to change into two screen. I cannot do that. All right.
You may proceed,
So you
Prof.
can see like I'm presenting PowerPoint with some small slide at the end, at the edge, yeah?
Yes. Yes.
All right. But
Okay,
you
you may
can still
proceed,
see
Prof.
the slide. I hope
Yes.
all of you can still see the slide, yeah?
Okay.
All right. Okay. Now I'm on the page of engineered timber product. Is it okay? All of you? Can Dora screenshot the screen now? Let me see. Share with me from my phone. I want to see how small is the slide to all of you. Somebody has to
Okay,
help me.
Prof. So you may proceed. So now we are at the slide number 3.
Okay, the engineered timber product. All right. So these
Okay.
are the common engineered timber products that available overseas. Okay, which is laminated element, which is glue laminated timber, and we have cross laminated timber. That's the most common engineered timber product. And then we have other structural wood product, laminated vinyl lumber, parallel strand lumber, laminated strand lumber, oriented strand lumber. So these structural wood products are manufactured using strand or strips of wood. So that means the whole log can be converted into a structural product. So the sawn timber can be made into glue laminated timber, can be made into cross laminated timber in the solid form, dowel laminated timber, which is each element are being connected with dowel, or it can also be connected using nail. So the glue lamp and the CLC are joined together using glue. So once you cut the sawn timber, you still have remainder of unused timber product, timber pieces. You can make it into strips or into strands that you can make them by using glue into and convert it into laminated vinyl lumber, parallel strand lumber, laminated strand lumber, and so on. So the whole lot can actually be converted into structural elements. Now, with this new technology in the timber product, the innovation in the timber construction has changed. Okay, from the kampung houses, which is from the kampung houses which just use the solid timber, they now change into light timber structures. And then with a new technology of glue lamp, they can make into engineered timber frame product. And then after that, by converting into cross-laminated timber, they make it into engineered timber plate, and then the revolution in the construction change. You can build more high-rise building and in much faster construction time. And in order for the stability of the high-rise timber structures, then you can make it into hybrid and stiffen it with steel, or you can have it in concrete and so on. So it becomes in hybrid because the requirement in the design for the timber tall structures are different. Okay, especially when dealing with the earthquake and also the wind and so on. So the stability. So there's a place where the hybrid construction can take place. Now, what is light wood system? before I can show you how the technology are required into constructing this material and how the technology can be used in the production of this material, let's get some knowledge on what are the different form of element of timber that can be used for construction. Now, I will not touch on the kampung houses, yeah, because these villages are not being designed. The houses are not designed using any codes, so the safety are not being considered in the construction of the villages houses. All right. So in the design, in the building of this type of housing, yeah, the research or the new technology, the specific standards need to be followed. Yeah. So the development of the standard is required. All right. For light wood system, a combination of studs and also the panel. All right, so they make it frame using solid timber and clad it or cover it with other timber products, which has such as oriental strand board, or you can, in this photo is oriental strand board, or you can use plywood. And this one still by manually, or it also can be done in the factory by arranging the studs. Okay, so the time taken will be much longer, all right, in order to construct this type of product. But it is a very easy and in the beginning. Okay, this is the common construction method that we use in Europe, especially in US and so on. Now, but the construction of this type of building will not normally do beyond 3 or 5 stories building. Okay, so the example of the common example of the building that using timber frame product are in the houses, yeah, and most of the 90% of homes in Canada and US are light wood frame system. So, but from outside, it looks like they are made from concrete. They are just using the facade from those different materials, but the frame is actually from timber. And also they can make a few stories building by using the same prefab light wood panel system. Okay, and there are different types. They have elements which can be used for roof truss. The element of frame can be in the eye joist, and they can make it into panel, and the other day it can make into modular system. I wish we can have it in Malaysia. I want to build my house on the land. I want to build a house. I can go into internet or into any company that provide this modular and order it online. And then after 1 week, my house is ready. That would be very beautiful. Okay. And in order to assist in the construction and in the production of those elements, either the I-joist or the panel or the modular system, all right, so the IT has to be used, all right, in the design. Okay, we can use a BIM software, we can use structured software in designing the house or the building. But in order to construct the element, the wall and so on, we can use automatic or semi-automatic production equipment. And you can compare between doing by this kind of production and the manual, the time required, the time comparison is so huge. Yeah, so this one can be done in a few hours or in a few weeks. I'll show you one video at the end that will tell you how long it takes to construct certain houses by using the prefab light wood structure. Another product that is now getting more popular even in Asia, in Singapore, in Japan and so on, are the glue laminated timber and also the cross laminated timber. So the glue laminated timber are constructed by laminating sawn timber. All right, it's graded sawn timber because it's for structural application. It has to be graded properly. If not, it will not be able to carry the load. There is a do and don'ts when we manufacture the glue laminated timber, but I will not go into detail. only half an hour. All right. Then the application of this glue laminated timber, it can be in the form of different sizes, because for solid timber we can't do this kind of construction, because the maximum size that we can get by using solid timber in Malaysia, which is in the economy part, it is quite considered affordable, is 100 mm width. All right, if you go beyond that, the price will go up, because from one log to get a good quality of more than 100 mm width of sawn timber is very difficult because of the natural defect that has in the timber. All right, so because in order for us to make it into structure, the number of defect allowed in each piece, there is standard that we need to conform. If not, that piece of timber cannot be used for structural application, because the strength will be reduced so much. It depends on the defect inside the timber. That's why we have to do the grading. So by doing the engineered timber product into glue lamp, the size can be changed depending on how the factory, how the machinery allow this type of fabrication can be done. Okay, so this shows some of the example of the glue laminated timber, and you can compare between a normal Asian person with one of the beam. You can see how big is the beam, right? So this is by using timber. If I using solid, no way we can do that. And you can see how it applied into the bridge of 1.75 meter width of bridge. So compared to the size of solid timber, the maximum and the most reasonable price that we can get is 100 mm. All right, this is 1.75 meters. Therefore, by manufacturing into engineered timber product, this type of construction is feasible. Yeah, it's feasible. Okay, the same. This is one of the examples. 2.4 meter beam. All right, and the length is 45 meters. Okay, and the application of the timber can be yeah, because this was supposed to be in the slideshow. Okay, so these are how now by using engineered timber product and by using special machinery, the material can be curved. Yeah, but for solid timber, it's quite curved, and then this can make shows the beauty of using timber. So this allow architects, to be more imaginative when designing the structures using timber. So by using the engineered timber product will allow flexibility and creativity in the design of the timber structures. Okay. Now again, by using engineered timber product, you can build the structures higher and higher and higher. All right, and these are some of the examples of the construction of the timber building overseas. Similarly to these are the history on the development on the tall story building by using timber, from 3 to 5 stories to 30 stories in Vancouver, Canada, and then 34 stories in Stockholm, Sweden. Yeah, so there are other, the potential of building high-rise building is much more there. Now what is happened in Malaysia now? Do we have buildings that built using engineered timber product? Yeah, we have, but these are still very new. The application of engineered timber product in Malaysia is still considered new, but not necessarily new, because the first building, commercial building that we built using engineered timber product, glue lamp, is in 2011. Now it's already 2021, it's already 10 years. So within that time frame, the popularity of using engineered timber product is still very low in Malaysia. So we need to promote more and more, because we know that timber product is sustainable material, and we are going for green building material. So timber is the most perfect material that fits in that category. Okay, so this is in the Johor Bahru, and we also have one in Milan using during the MITI exhibition pavilion. So our pavilion is made from glue laminated timber. And then we also built the TLDM remote, yeah, the multi-purpose hall using, because of at the seaside, at first it was designed using steel, but because of the corrosion, we proposed to use timber, and the costs are the same. And in fact, we still make profit by using that, because at that time, the application of timber comes later. So if from the original design, we are using timber, the cost of the foundation can be much less. So the overall cost can be reduced. And we also have one in Semenit, yeah, CFRC building, and the Ritz-Carlton Hotel and Resort Langkawi. And we have also used it in the building the restaurant in Johor Bahru. There are few restaurants that built using glue lamp, and it is very impressive, yeah. Now, we also in Malaysia try to move to another famous product in Europe, in US, and so on in the overseas. Is a cross-laminated timber, because now people are crazy about using this type of product in the constructing of the tall story building, huge commercial buildings, because of the fast construction time. All right, so this is my research that I work together with two factories in Europe, because we don't have factory in Malaysia constructing the CLT, and we don't have the standard available in producing the CLT. So in order to allow our Malaysian factory to produce the CLT, so we need to provide standard, manufacturing standard, because the timber, European timber and Malaysian timber are different. The requirement in the production will be different, the pressure, the glue, and so on. So in order to develop the standard of manufacturing for Malaysian, for the CLT using tropical hardwood, I have to produce the CLT in the current commercial factory in Europe, which is there are two different types of production, one by using vacuum press, another one by using hydraulic press. So we choose two different factories to produce that, which is in Germany and also in Italy. Okay, so this is some of the examples during our production. So we have produced the first CLT from tropical hardwood in Europe. Yeah, so now our standard in developing, we are in the stage of developing the standard. So inshallah, once the standard are available, then the factory can take it up and then produce the CLT for Malaysian industry. And the CLT can be used, yeah, in the building like this. It's very fast. By using panel, you just connect like Lego, yeah. But it has to be a proper design. Definitely, it has to be proper design. The design values must be there. So that's opened up a lot of opportunity for Malaysian researchers to work on this one, to come up with, because we have more than 3,000 timber species. So each of the timber will have different properties. So they open up a lot of opportunity to develop the strength properties for design purposes. If you want to use the CLT from Malaysian timber. Europe, they have the standard. They already identify a few species only for the production of CLT for the glue lamp, because their number of species are very limited compared to Malaysia. Now, they have moved from low-rise building into commercial building, into mid-rise building, into high-rise building by using CLT, and the construction is very much more easy to handle, much more faster, because we are talking about money when we are dealing with construction. So we want to save a lot of financial part in that sense. So these are the best product to use. And we can see that in modern wood construction, as I mentioned before, from light structure into engineered timber frame to engineered timber plate, which is from CLT, engineered timber frame from glue lamp, that's now light structure from using solid timber, and then you can have into hybrid system. Now, how Industry 4.0 is driving the innovation in timber construction, okay? So in the current and future scientific and technology worldwide panorama, cutting-edge computational and visualization and fabrication techniques play a critical role for the development of the new wood products that bring innovation into companies and ultimately improve the quality of life for the society. And we know that the information technologies play an integral part in architectural design, yeah, because the architect will do the form and concept, by putting into information about wood sign and then transfer it into the civil engineer in order to do the construction. All right. By using information technologies, it will be assist in the construction of the timber structures. Okay, now new advanced manufacturing technique, because when we are dealing with huge amount of timber to be used in the construction of tall buildings, manually is no. All right, so we need to have a new advanced manufacturing techniques that combine the Internet of Things to enable the concept to create a digital manufacturing enterprise that is not only interconnected but communicates, analyzes, and using information to derive further intelligent action. Okay, in order for us to produce thousands and thousands of tons of timber product in order for us to use in the construction, for example, like this. Just imagine if you have 30 stories, 40 stories, how much volume of timbers are being used. So if you want to slice the timber by using normal sawn and then make it into engineered timber plate, that will be ridiculous. Yeah. So therefore, the IoT is needed. Okay. Now, during the golden age in the past, okay, this example is still standing, yeah, the pagoda, yeah, in China. The fabrication process will focus on either manual work or mass production of single elements. Although these techniques are elaborated and efficient, they are also inflexible. This is the reason for an increasing amount of interest in computational design and fabrication process, as well as the use of industrial robots. Digital fabrication substantially expands the range of manufacturing process possibilities and offers more freedom for developing innovative, material-oriented, and adaptive construction system. Now, you can compare between this building in the golden age. The carpenters are doing their job and skillful, yeah, in that sense, but the sizes may not be the same. But now looking at this building in the digital age, the new advanced manufacturing techniques combined with the Internet of Things are enable the creation of digital manufacturing enterprises that is not only interconnected but communicate, analyze, and use information to drive further intelligent action in the physical world. The digital age in manufacturing is revolutionizing how we design, develop, fabricate, distribute, and consume products. Wood is the world's largest construction material by volume, renewable, and sustainable. The world today is profoundly dependent upon wood, paper, and other wood-based products in a wide variety of ways. With an increase in demand for building materials that are sustainable and renewable, wood-based material will be an even more important part of our daily lives in the future. Yet, there is a gap between the potential of computational design and digital fabrication and current construction methods that utilize wood. Our main goal is to close this gap and bring greater sustainability to future construction materials and methods. All right. So manufacturing has undergone many evolutionary stages and paradigm shifts. The paradigm shift is going from a craft industry to mass production, then lean manufacturing, and finally to agile manufacturing and mass customization. The digital age in manufacturing is giving rise to output devices that allow rapid customization and manufacturing, revolutionizing how we design, develop, fabricate, distribute, and consume the product. So we can see that from using manual into cyber physical system under IR 4.0, so the timber industry also has changed and moved to that. Okay, so I now want to share you the IR 4.0 for the timber industry. It will take some time, about for a few minutes.
Sorry, Prof. We cannot see the video actually.
Yeah.
We cannot see the video actually because in our
Tak boleh?
screen here it's not. We cannot watch the video.
Oh my goodness. Why? But can you? Oh, that's a problem. That's why I sent you guys the. So what do
Yeah.
I do now? So I cannot show.
If you have it at,
Now you can see or not?
yes, now we can see. Okay, thank you.
I think I can stop now. I think I've already give you some of the ideas on how the IoT have been used in the production or in the construction of the timber building by using light frame structures. Similarly, when we are doing for Blue Lamp and also for the CLT. Okay.
Okay, Prof.
Okay, I thought I will take so much time. All right. Okay. Now, research on Industry 4.0 is relatively a new topic. Yeah, the term is well known not only in academia but also in the industry. By definition, Industry 4.0 or the fourth industrial revolution refers to the Internet of Things and the Internet of Service integrated with the manufacturing environment where all industrial businesses around the globe connect and control their machinery, factories, and warehousing facilities intelligently through cyber physical systems by sharing information that triggers the action. So with that, there are a lot of research opportunity for us here at academia and also for the industry to work together in different areas. For example, in the design. The parametric design, simulation, generative method, highly complex architecture, manufacturing, fabrication, and assembly by using 3D printing, CNC, and robotics. Information material, we can also apply smart material that responds to the stimuli and can incorporate sensors, transmitters, also novel wood-based 3D printing materials. So this can show the synergy between civil, mechanical, electrical, computer science together. Yeah, especially in Malaysia, we are very limited in this information. Smart system and structures, how to do the mandatory system, digital control, interactive building elements, and then visual engineering, network, virtual reality tools that open up new ways to work together and bring new forms of collective creativity to design and also the architecture. The research will have specific focus, computational mechanical modeling of wood, because right now the software that available are using the data from softwood timber, so very lacking in the tropical hardwood. Computational design modeling of wood-based product, advanced timber structure, 3D printing, robotic fabrication in timber construction, digital fabrication and design in mixed realities environment, wood in the arts, computational approach to artistic wood design, business innovation in the wood industry in the digital era. So these are open up, yeah, the new era of research in the timber construction in Malaysia. Okay, so we have to think about not just looking at the properties of the timber alone. Okay, that would not put us far advanced in the area of timber construction in Malaysia. And to materialize the dream of having tall and huge timber building in Malaysia, there are few strategic approach, which is education and training. University develops in wood lesson, investigation, training for engineers, architects, and technicians. We have to visit manufacturers and we have to learn from them how they manufacture the product, what kind of machinery that are being used, how this can be, the idea can be imparted to the Malaysian timber industry. And at the same time, with doing the design, we have to have head twist. We need to see how they design, okay, what kind of software they are being used, whether that can be applicable to our industry, how we can incorporate that in our teaching and learning in nature, how we can change our syllabus so that it can impart this information for the advanced technology in timber construction. We have to go on site tours because when dealing with the new material, we are lacking with workers that have this skill in the construction. We have to train the workers, but how to train the workers? We also need to have that information. We have to be trained in that, so we can get IR in this area. All right, not only IR in concrete structures, in steel structures, in the other infrastructures material, but we can also have the IR in the specific timber construction. Okay, so with this talk, I throw these ideas to all the participants here. These are a lot of opportunities that we can work on, and how we can bring this timber construction in Malaysia into reality. So with that, I thank you.
Okay, thank you to Yang Berbahagia Profesor Dr. Zakia for your wonderful and fruitful session. So maybe we can have a session on question and answer, okay, from the audience. So we have a question here from Dr. Ng Kok Chen. So does Malaysia government provide any incentive to promote the use of timber in construction industry?
Okay, when we first introduced glue lamp in Malaysia for commercial building, for example, like in Johor Bahru that we built and a few other glue lamp projects. So one of the factory in Malaysia have this incentive from MIDA, which is 5 years without tax when they're producing that. And the MTIB also provide loan for the industry to start this industry in Malaysia. Yeah, there are incentives from the government. You just need to know where to get it. Yeah.
Okay. So there is an incentive that is provided by the players to the players of industries, so that we can have that incentive, especially on the tax exemptions. Okay, Prof, I have one question from me myself. We see that the latest one, we see that the Tokyo Olympic 2020 stadium is actually using timber as its main structural system, which is a very wonderful construction. They showed during the opening. So what kinds of factor is actually need to be considered in constructing a mega structure like stadium or tall structure in choosing timber as the main system?
Okay. Now, it's just like a normal design of other timber, tall building using other construction material like concrete and steel. So when we designing the building, of course, we need the properties, the structural properties of those materials. So for concrete and steel, the properties are available, available.
Yeah.
When you use it in your working, similar, grade 50, grade 50, grade 40, grade 40,
Yes.
all the same. But for timber are different, unless you want to import the product from overseas and use it local. But is the performance of that timber to mention whether are the same or not. Whether they can provide the durability in Malaysia with that pouring rain, yeah?
Yes.
Or whether they have snow, they incorporate that situation already. They already cover that situation, the requirement of snow in Europe. They have it in design, and then the construction also they have that protection. Okay, I have a lot of photos when I visit the overseas during that construction. They have a lot of techniques in order to do the protection. So, like in Singapore, they import timber from Finland. If you go to now, Singapore are building a lot of timber structures. Yeah, the university are building using that, but they have problem with durability. Okay, because of their softwood, they are not suitable for our weather. So we are promoting using tropical hardwood. But if we want to do using tropical hardwood, are the data available or not? Yeah, so that's one thing. So we have that. All right, and then another parameter that needs to be considered when building the timber structures in Malaysia is the fire requirement. Okay, it's a fire requirement. Okay, so the uniform building bylaw. All right, you have to conform to uniform building bylaw when you want to design tall buildings using timber to be protected from fire. It's a very concerned issue in Malaysia. So these are the parameters: durability, and also the strength properties, and also the fire requirement. That one have to be taken care of. But design, there are design standards. You can use Euro Code 5 and to design the timber structures. Yeah, but then it says that inside that standard, they have properties for softwood and other European hardwood, but they don't have value for tropical hardwood. So this has opened up a lot of things. That's why my research for the past 18 years, I'm actually working on that because I foresee that, you know, if I know for us to go for sustainability material, in order for us to embrace the SDG in construction, we have to use sustainable construction material. So the timber
Yeah.
are one of the most product that can be do. But I can foresee that we have problem in that time that in designing whether our standards are there to support the engineers and so on. Are there standards to manufacture those products or not? Are there companies that wants to invest in that product or not? Okay, so is there skilled people, skilled workers that can do the construction? Even though the architect, engineer has designed, but do we have skilled workers or not to do that construction?
Yes.
So these are in my project, Okay, I do research to determine the properties. I develop standard on the manufacturing, on the design, then do a training, okay, and bring the interested party overseas to get training in overseas through my contact. So that's why actually I'm going to retire soon anyway. So that's why I want to promote this to other researchers. If you are interested in working in this new era in Malaysia, yeah, so there are a lot of opportunities. I've shown you some, but not only looking at the properties, basic studies. No, now we want to incorporate IR 4.0. How to move the industry current practice into IR 4.0. The investment has to be there, but the computer system are not using the properties of ours. You know, they are not
Yes.
recognizing when you are doing grading. No, currently while doing visual grading, we look at piece of timber, but you have a huge volume, 500 tons at one time to produce the house. It's ridiculous for one man show to grade the timber. So we have to do machine, but the machine that we bought from overseas cannot recognize the defect for our local timber because it's already
Oh,
computed and input the data based on their timber. So these are another IoT system that be able to recognize nation people in order for them to do the grading. So that there must be working together between a computer science lecturer who can know how to do that, mechanical, electrical, to develop a new software that be able to
yes.
detect, okay, and then mention that, okay, this timber is in D40. Okay, when we pass through the timber, the system will recognize that is D40, D50, D60, or as what it will select standard, common, you know, these are the different values. That is one very simple IoT that is lacking right now in Malaysia. That's a beginning, it's a basic. Not yet in the production side, it's not yet into the factory production. So that's open. Me alone and a few group of researchers alone will not be able to move fast in this industry. Yeah, so not only UITM has to work on this, the
Yes.
whole other university has to take part on this in order for us to, because we should have our target in what year that we want to see this thing. But in order for the industry to take up this basic information has to be ready also. So that comes to university. University have to work with the industry. Industry wants what? The university can provide. The university have the idea. If the industry can pick it up or not. So these are the things. Yeah.
Okay,
Can you
Prof. So
work
we
on?
have another question. We have another question here.
Yeah.
Maybe the producer can pin the question here to Prof. Okay, from Dr. Hong Pin Lee. Up to date, is there any innovative way to preserve timber so it can be more durable, especially to be used in Malaysia, wet and moisture condition? We know that the weather condition here is really can easily affect the timber. So you may answer this question, Prof.
Okay. Of course, in Malaysia, for our timber, there are a lot of studies done by FRIM, especially, and UPM on the durability of timber, how to protect the timber. what kind of chemical can be used in order for us to treat the timber. Yes. There are a few basic treatment chemical that available, whether it is environmental friendly based or it is not environmental friendly based, boron or something like that. Yeah, QNAP are available. It's just that a lot of study also have to be done because because our timber are hard, high density. For example, like uh, um, a species that is not under ST2, is not naturally durable. All right, the density can be 1,000. For that timber to absorb the chemical is very difficult to protect. So you can do by coating or by soaking it into chemical. Yeah. So one more thing that I need to encourage is the industry has to be sincere when they are doing the protection, doing the treatment process. Yeah, in order, because when we say that there is a test to see whether the timber is actually treated or not treated. But we do understand in our standard requirement, the absorption, there will be requirement for that absorption and so on. But sometimes it's quite difficult to be complied to our timber. So again, okay, now again, I want to mention that we always adopt or buy for the chemical from overseas to do the protection. The study done on that chemical is on their wood. So this again, I already mentioned to some of the chemical engineering staff and also from the plant science, try to develop a new treatment that's suitable for our product. Okay, so this also again open up. So I will not cover into that. I'm not chemistry based, so I will not do that. But I can say that there is a lot of opportunity there for researchers to explore or develop treatment that's suitable for local people. Yeah.
Okay, thank you to our honorable keynote speaker, Professor Dr. Zaki Ahmad, for fruitful sharing session. On behalf of the organizing committee, I would like to express my gratitude for your time and knowledge that you share with us today. Thank you again, Prof.
Okay, thank you for inviting me. Yeah. Assalamualaikum warahmatullahi wabarakatuh.
Okay, ladies and gentlemen, without further ado, I am honoredly would like to invite Yang Berbahagia Profesor Teknologis Dr. Salmiah Kasolang, Rektor Universiti Teknologi Mara, Cawangan Pulau Pinang, to deliver her speech and officiate the International Conference on Advance in Civil Engineering and Science Technology 2021. Please welcome Prof.
Technologist Muhammad Samsudin. It is my pleasure to deliver this opening. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya wa mursalin wa ala alihi wa sahbihi ajma'in. Yang berusaha Associate Professor IR Dr. Ahmad Rashidi Razali, Deputy Director Academic and International Affairs. Yang berusaha Associate Professor Professor Dr. Nur Azia Bahari, Deputy Director Research Industry Community and Alumni Network, UITM Cawangan Pulau Pinang. Yang berusaha Teknologis Dr. Muhammad Rozaiman Aziz, Deputy Director Student Affairs. Yang berusaha Dr. Haji Anas bin Ibrahim, Head of Centers of Studies, Civil Engineering Studies, UITM Cawangan Pulau Pinang. Yang berusaha Associate Professor Technology Dr. K. Dora Abdul Ghani as the Conference Chair of Icacest 2021. Respective keynote and plenary speakers, Honorable Professor Dr. Zaki Ahmad, Dean Research and Innovation, College of Engineering. Apa khabar, Prof? Sehat? I hope sehat, Prof. Alhamdulillah. Associate Professor Dr. Sanjay Kumar Shukla, Department of Civil and Environmental Engineering, School of Engineering, Edith Cowan University, Australia. Associate Professor Dr. Zhu Zikong, School of Transportation and Traffic at the Beijing Jiaotong University, China. Presenters and participants of the International Conference on Advances in Civil Engineering and Science Technology, Icacest 2021. Assalamualaikum, peace be upon you, good morning, and salam sejahtera. Alhamdulillah, let's extend our sincere gratitude to God, Allah subhanahu wa ta'ala, for giving us the opportunity to hold our international conference on advances in engineering and science technology 2021, organized by Civil Engineering Center of Studies, University Technology Mara, Pulau Pinang branch. I'm delighted to welcome all of you to our virtual conference, which brings together experts and academics from around the world. Firstly, I would like to thank the organizing committee for giving me the chance to address you today in this international virtual conference with the theme Re-engineering cultures of science and technology in creating sustainable development through IR 4.0. This conference is particularly in line with the IR 4.0, where we want to re-engineer the culture so that we can boost up the sustainable development in the field of science and technology. This is in line with our university's strategic goals to become the globally renowned university in the year 2025. What is the re-engineering? Based on the dictionary, there are two terms in defining the meaning, which are underproduction and management. Underproduction, it defines re-engineering as a process of changing and improving the design of a product or system. Meanwhile, management, it defined as the process of changing and improving the way a company works, the way a job is done. But for the TQM, as I also teach TQM, there are two things when we use re-engineering. Re-engineering we use when we want to make a very a big change, and it is more costly compared to what we call Kaizen. Kaizen is a more subtle change that does not cost so much. So re-engineering is actually a big word in some contexts. Therefore, it is very important by exploiting the information technology in this new era in improving the design of a product or a system that related with the science and technology field. Ladies and gentlemen, based on a study, Malaysia.com mentioned that from self-driving cars to drone-delivered online shopping, the fourth industrial revolution is changing how we live, work, and communicate. More and more jobs being taken over by artificial intelligence, AI. The fourth industrial revolution has changed the way we live, work, and communicate. It is also likely to change the things we value and the way we value them in the future. Presently, we can already see changing business models and employment trends. IR 4.0 has allowed us to witness the advanced technology being implemented, and it is very suitable with the current situation of pandemic, especially in the teaching and research industry, when most of the science and technology field have a limitation in doing research that involves real testing. With that, by re-engineering cultures of science and technology in creating sustainable development through IR 4.0 will not limit us in continuing what we normally do and in gaining knowledge and contributing to our country. Therefore, I sincerely hope that this conference will be the best platform to share our experiences and practices in science and technology field, which provides valuable opportunities for all of us to exchange ideas and think deeply about what we can do to attune to the demands of the re-engineering cultures of science and technology in creating sustainable development through IR 4.0. The challenging part is sustainability. How would we sustainable our program, our process, and whatever we do? I also believe that this conference will facilitate networking, information exchange, and collaboration among educators and practitioners all around the globe. Before I end my speech, I would like to thank all the participants, the keynote speakers, reviewers, juries, and the co-organizers for organizing this conference. They are Institute for Infrastructure, Engineering and Sustainable Management, IEESM, Structural Engineering and Seismic Research Group, SISMOS, Permanent Way Infrastructure Research Group, UITM, and Rehabilitation, Repair and Retrofitting Research Group, 3R. The strategic partners are University Science Malaysia, USM, University Malikus Saleh Indonesia, Construction Industry Development Board, CIDB Malaysia, Construction Research Institute Malaysia, CREAM, and King Mongkut's Institute of Technology, Lakrabang, Thailand. The sponsors of the conference are Paramount Property Utara Sdn Bhd, New Rocks Technology Concept, Mikabina Trade, Nazita Patisserie, and Megajati Academy Sdn Bhd. All right. The organizing committee and everyone who has worked tirelessly for making sure that this conference will become a success. Even though we are only meeting virtually, I hope this conference will be a window to a better understanding of the challenges and opportunities that each of us has to go through in facing and overcoming COVID-19. With that, Bismillahirrahmanirrahim, I hereby declare the opening of the International Conference on Advances in Civil Engineering and Science Technology, Icacest 2021. Thank you. Wabillahi taufiq wal hidayah. Wassalamu alaikum warahmatullahi ta'ala wabarakatuh. Over to you, Dr. Samsudin.
Thank you Yang Berbahagia Profesor Teknologis Dr. Salmiah Kasolang for officiating the International Conference on Advance in Civil Engineering and Science Technology 2021. Before we end our opening and keynote session, there is an announcement to all participants. The parallel session will be commencing at 10:40 a.m. Please join the parallel session room by using the link shared in the program book by following respective room 1, room 2, and room 3, or you can access it in our official website. Please be in the session 10 minutes before the parallel session is starting. That is to mark the end of the opening ceremony of the International Conference on Advance in Civil Engineering and Science Technology 2021. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.